Have you ever thought about how it's possible to have two totally different worlds, like right next to each other? I'm talking one place that's all lush and green, and another that's bone dry and barren. Well, believe it or not, sometimes the only thing standing between them is a mountain. So today, let's dive in and find out how mountains become these incredible weather-making machines.
I mean, just look at this. On one side, you've got this vibrant, green ecosystem just bursting with life, getting all the rain it needs. And then, bam, on the other, a stark, dry landscape that looks like it's from another planet. And the wildest part? These two places can be just a few dozen miles apart.
So, here's the big question we're tackling today. What if the only thing causing this crazy split in climate was a mountain range standing in the way? It sounds almost too simple, but the science behind it is it's awesome.
Okay, so picture this. Our story has two main characters. You've got this huge mass of moist air just cruising along, and then you have a giant, immovable mountain that's parked right in its path. Well, something's got to give, right? And in this case, that air has no choice but to go up and over.
Now, this whole process has a pretty cool scientific name, orographic precipitation. I know, it's a mouthful, but it's actually really simple when you break it down. Oro is from the Greek word for mountain, so it literally just means mountain rain. And that is the key concept for our whole explainer.
All right, let's follow that parcel of air on the first leg of its journey, the long climb up what we call the windward side of the mountain. That's just the side that's facing the wind. This is where all the action starts. The whole thing really boils down to 4 steps. First, that moist air is forced to rise. As it gets higher, the pressure drops, which lets the air expand, kind of like a balloon floating up into the sky. Well, that expansion makes the air cool down. And finally, once that cooler air gets saturated, meaning it just can't hold any more water vapor, it has to condense. That forms clouds, and then, you got it, rain.
So what's the result? Well, this side of the mountain gets absolutely drenched. It's usually not a crazy, violent downpour, but more of a steady, long-lasting rain that really soaks the ground. And that's what creates those beautiful, lush green landscapes we saw a minute ago. But that's only half the story. What happens after the air gets to the peak? It's already dropped most of its moisture, and now it's got to go down the other side, the leeward side. This is where the plot thickens, creating something we call the rain shadow effect. And what happens here is pretty much the exact opposite of the trip up. The now dry air starts to descend. As it sinks, the pressure builds, and the air gets compressed. You know how when you pump up a bike tire, the pump gets hot? It's the same idea. All that compression causes the air to warm up, and it warms up a lot. So what's the upshot of all this? Well, as that air gets hotter, its ability to hold on to moisture goes way up, which means its relative humidity just plummets. This warm, dry air is terrible at making clouds. So on this side of the mountain, you get very little, if any, rain. Period.
And this dry zone has the perfect name for it, a rain shadow. It's like the mountain is literally casting a shadow that blocks the rain, creating that super dry landscape we started with.
So let's just put this all side by side to make it super clear. On the windward side, air goes up, expands, and cools down, which gives you a ton of rain. On the leeward side, the air comes down, gets compressed, and warms up, creating a dry rain shadow. It's a tale of two sides, all thanks to one mountain.
Okay, so this is a really cool weather phenomenon for sure. But so what? Why does this actually matter? Well, this whole process doesn't just make a little rain here and there. It has a massive impact on entire regions, shaping everything from our water supply to where we can even build cities.
Seriously, understanding this is vital. This process controls huge rainfall patterns and decides how much water ends up in our rivers and reservoirs. It's the reason why a city can be thriving on one side of a mountain with plenty of water for everything, while just over the ridge, another community is dealing with constant drought. For engineers and water managers, this stuff is absolutely critical.
So if you take away just one thing from all this, let it be this. Mountains are not just sitting there. They are active, powerful forces that create predictable weather patterns, causing these insane differences in climate over incredibly short distances.
Yeah, the next time you look at a mountain range, don't just see a big pile of rock. See it for what it really is. A giant, natural weather-making machine working 24/7 to separate the wet world from the dry one.
It's an amazing system, but it does leave us with a new puzzle, doesn't it? What happens when you get huge amounts of rain over flat land, with no mountain anywhere in sight to give the air that upward push?
Well, that's a whole different kind of weather system, and we'll tackle that one next time. See you then.